Perhaps no other treatment in the history of medicine has generated such strong opinions as chelation therapy. The majority of physicians still view this as nothing more than quackery. Yet, in spite of this opposition, chelation therapy continues to gain widespread public support among the millions who have personally experienced the benefits of this remarkable treatment. Part 1 of this video will help to explain in simple terms what chelation therapy is and how it works scientifically. In Part 2, patients who have taken this therapy tell their own stories about what chelation has done for them. Chelation therapy is a treatment given intravenously under the supervision of a thoroughly trained and licensed medical doctor. Just prior to the treatment session, a registered nurse prepares the intravenous solutions. The ingredients in each patient's intravenous container are introduced in a sterile fashion using all disposable supplies. The dosage of the ingredients are individualized for each patient, according to the patient's height, weight, age, sex, and kidney function blood test. Once the patient arrives to the clinic, a tiny intravenous needle is placed in the hand or arm. The patient is then escorted to a comfortable recliner chair where they relax while the solution is slowly administered over the following 2.5 to 3 hours. A computer-controlled pump is used to ensure that the solution is dripped into the vein at a carefully prescribed rate. All of these exacting procedures are used to ensure that the treatment is given with the utmost of safety. Serious side effects from chelation therapy are extremely rare. In fact, as long as chelation therapy is administered according to proper protocols, statistically speaking, the treatment itself is probably even safer than the trip to the clinic in a car. The chelation solution contains several important ingredients: EDTA, magnesium, vitamin C, and B vitamins. Each ingredient is important, and each plays a role in the effectiveness of the chelation treatment. EDTA, or ethylene diamine tetraacetic acid, is a synthetic amino acid which has been used for over 40 years to treat poisoning with lead and other toxic metals. When dripped into the bloodstream as an intravenous treatment, it circulates throughout the body like a non-toxic detergent, cleansing away calcium deposits in hardened arteries, as well as toxic metals and accumulated iron in tissues and organs. Once EDTA has captured the calcium or metallic waste, it circulates throughout the bloodstream until it exits the body through the kidneys. Having a chelation treatment is almost like having a shower on the inside. The other ingredients, magnesium, vitamin C, and B vitamins, are all used to increase the cleansing properties of EDTA, thus making the treatment more effective. Chelation therapy is known to work through well-understood scientific principles. In fact, this treatment helps to address some of the basic reasons why we develop chronic illnesses later in life. Clearly, one of the most important medical breakthroughs of this century was the discovery that most diseases related to the aging process are caused largely by an overabundance of toxic substances known as free radicals. As we will soon see, chelation therapy reduces these damaging free radicals more effectively than any other treatment currently available. Here is a common example of free radical damage. A fresh apple is cut open and exposed to the air. In a few minutes, the apple turns brown from free radical damage. Damage caused by free radicals requires oxygen and is known as oxidation. Because our bloodstream is full of oxygen, free radical damage takes place very readily through the process of oxidation. Free radicals are molecules which have undergone changes making them highly unstable. This cartoon illustrates a stable molecule. The two wheels on this cartoon molecule represent electrons spinning around the outermost part of the molecule. A molecule with all of its electrons in pairs is stable. However, if the molecule loses an electron, it becomes unstable. This molecule is now a free radical. It is so unstable that it will spin around until it collides with some other molecule, causing damage in the process. Three things are necessary to make a free radical: a stable molecule, oxygen, which loves to steal electrons from stable molecules, and a metal or calcium atom. When oxygen approaches a molecule, it tries to steal the molecule's electron. This does not happen readily if oxygen is all by itself. However, if an electron-conducting metal or calcium atom is nearby, the metal or calcium will act as a catalyst to strip off the electron from the stable molecule. Now, the oxygen is an unstable free radical with an extra electron, and the molecule has also become an unstable free radical. Inside the body, if calcium or metals such as lead or iron begin to accumulate in cells, the cells suffer massive amounts of free radical damage or oxidation, eventually resulting in diseases of the aging process. This is because metals and calcium are free radical catalysts. One way we can help to reduce free radical damage or oxidation inside our bodies is to consume adequate quantities of antioxidants. Eating lots of fruits and vegetables, as well as taking supplements such as vitamin C, vitamin E, grapeseed extract, or ginkgo biloba, are all ways to increase our intake of antioxidants. Antioxidants are molecules with electrons to spare. When an antioxidant encounters a free radical, it donates an electron to the free radical, turning it back into a stable molecule. Scientists actually refer to antioxidants as free radical scavengers. However, antioxidants cannot remove the source of free radicals. In our modern industrialized world, the major source of excessive free radicals in the human body are environmentally derived toxins such as lead, arsenic, mercury, and aluminum, as well as abnormal deposits of calcium within cells. Thus, to diminish the source of excessive free radicals, metals and abnormal deposits of calcium must be cleansed from the body using techniques like chelation therapy. Chelation comes from the Greek word chelios, which means a claw. This cartoon crab represents EDTA, our chelation molecule. EDTA works because of its strong negative electronic charge. Metal or calcium atoms, on the other hand, all have a very strong positive charge. Thus, EDTA acts as a powerful magnet. It attracts and removes calcium or metal atoms that are polluting the membranes of the cells. EDTA cleanses pollution from the body, then leaves the body through the kidneys as a waste material. Within 24 hours, all of the EDTA has left the body, carrying with it a significant amount of waste materials that were polluting the body with damaging free radicals. The cells are then left in a cleaner, healthier state and are then able to heal themselves from the effects of free radical damage.